Okay, so first one, we know that this is a square root, invisible index of 2. So 60, 6 times 10. Remember, factor trees can look different, but the end result will be the same. Okay, so 60 is 2 squared times 3 times 5. Okay, so when you have an exponent inside that matches the index, you get to take that term in front. Okay, neither the 3 nor the 5 gets to move out. Okay, so don't leave your answer as 3 times 5. You should multiply it back together. Okay, problem 2, this time it's a cube root, so we need something to the third power on the inside. Okay, so 54's prime factorization is 2 times 3 cubed. The 3 moves out front. And the 2 stays inside the cube root. Okay, and then lastly, 4 times the square root of 50. So 50 is equal to 2 times 5 squared. Okay, so the 5 moves out to join the 4 that's already there. So when things get taken out front, they multiply what's already there. So 4 times 5, the new coefficient is 20. Okay, and just to remind you of the vocabulary for radicals, just like with x, a number in front, like 2x, 2 is the coefficient. Same thing with the radical. 2 cube root of 5, 2 is a coefficient. The little number in the top left of the radical, that's the index. It tells you what type of radical. And then lastly, the inside of the radical is the radicand. Okay, so we've worked with radicals a lot this year, but we've really only simplified them. Right, we've taken as much as we can from the inside to the outside, but we've never been able to like combine two radicals together. Okay, so that's what we're going to cover today, how to do various mathematical operations when radicals are involved. Okay, so first we'll talk about how to add and subtract radicals. Okay, so the first step you want to do is simplify each radical if possible. Okay, so just like we did above, that means if there's anything on the inside, meaning in the radicand, that can be moved in front to the coefficient, you would do so. Okay, so again, just like with x, you can't add all terms together, right? For example, 3x plus x squared, you can't combine those. Same thing with radicals. You can't add any two radicals together. So the rule is you can only add or subtract if both the index and the radicand match. Okay, so if either or both of those are different, you cannot add the two terms together. Okay, so out of the three parts, the coefficient, the index, the radicand, two of them need to match. The only one that's allowed to be different is the coefficient. Okay, so let's say that you do have matching terms. How do you actually add or subtract them? You add or subtract the coefficients and keep the index and the radicand the same. All right, so this problem below, -3 square root 5 plus 4 square root 12 plus 2 square root 5. Let's go through the steps in order, simplify each radical if possible. Okay, so one at a time, look at the radicals. The square root of 5 cannot be further simplified. 5 is a prime number, it's just 1 times 5, nothing is squared. Now the middle term, radical 12, here we may be able to simplify it. Okay, so I'll do my factor tree for 12. Okay, so we can rewrite 12 as 2 squared times 3. And that means we can take the 2 out to join the 4. Okay, so in the end, it simplifies to 8 radical 3. Okay, so again, the first term stayed the same. We weren't able to do anything with it. And what about the third term? Again, it's square root 5. 5 is prime, so you can't take anything out. Okay, so step 1 is complete. We've simplified each radical if possible. Next, we need to identify which terms are we allowed to actually add and subtract. Okay, so the first two, they are both square roots. They both have the invisible index of 2, but they have different radicands. This one has a 5, this one has a 3. So you cannot combine the first and the second radicals together. Okay, what about the first and the third? They do both have the invisible index of 2. They're both square roots. And they do both have identical radicands of 5. Okay, so we are allowed to combine these. Okay, it's okay that the coefficients are different. It's the other things, the index and the radicand, that need to match. Okay, so how do we actually combine them? You just add or subtract the coefficients, and you keep the rest of it the same. Okay, so again, in order to combine these two terms, you do the coefficients, so -3 plus 2. But then you just keep the radical 5. You don't make it radical 10, you don't make it 5 squared, the radical part stays the same. Okay, so over here, -3 plus 2 is -1. And then you put that in front of the radical 5. Again, it's -1 radical 5, but you don't need to write the 1. Okay, and again, you check, can these be combined? This is a square root, but the radicand is 5, so it cannot combine with the radicand of 3. Okay, so this would be fully simplified. So before I continue, any questions on the first one? Yes. Oh, so you're thinking of exponents. If it were like this, then you would move it to the denominator, right? But this negative is a coefficient. It's not an exponent. Okay, good. Other questions? Okay, so over here, same first step, simplify each radical if possible. Here, 18, can we do anything with that? All right, so 18 is equal to 2 times 3 squared. So we can take the 3 out to multiply the -2. So this part becomes -6 radical 2. In the middle, square root of 2. 2 is a prime number, so you can't split it up further. And at the end, 5 cube root of 2. Again, 2 is a prime number, so you can't split it up further. Okay, so now that we've simplified, can we combine? The first term is the square root of 2. The second term is also a square root of 2. Okay, so we can combine these. Okay, so you combine the coefficients, -6 plus 4, and then you keep the radical. Okay, and I'll just keep this one for now. Okay, so here, -6 plus 4 is -2. It's attached to the square root of 2. Okay, and then now can we combine these? They do have the same radicand of 2, but they have a different index. It's a square root versus a cube root. So that means that they cannot be combined. Okay, so we will consider this to be fully simplified. Okay, so I'll ask you to try out the 3 problems below. Okay, if you have any questions, feel free to raise your hand and I'll come by. You just keep whatever similar this term. Yeah. Oh, yes. Okay, so let's you or pull some stuff out of there. Okay. So now we check on the density size. So do any of this work have the same index? Yeah. I finished it. It's also a little project. But hold on. Yeah, it's not flat. But she said you wouldn't notice. All right. Okay, let me go ahead and go through these. First one, 7's a prime number, so you can't simplify. 3 is also a prime number, so again, you can't do anything. 12, we already did 12 earlier, right? 12 is 2 squared times 3. So this 2 can move out front. All right, so now I look to see what can be combined. The square root of 7 does not match either of the other two. So this first one will just stay how it is. But these two over here have identical square root of 3s. Okay, so you've got 7 minus 2, and then you keep it attached to a radical 3. Okay, so 7 minus 2 is positive 5. Okay, over here, now we're dealing with cube roots. So 4 is not a prime number, but it's only equal to 2 squared, right? That's not enough to take out of the cube root. Okay, so I'm just going to leave it as 4 because I can't take anything out. 24, what can I do with that? Okay, so 24 is 2 cubed times 3. So I can take the 2 out to join the negative 5 that's already there. Okay, so negative 5 times 2 is now negative 10. And then over here, 6 is 2 times 3, but nothing is going to get cubed. So we'll just leave it at 2 cube root 6. Okay, now you check what can be combined. These first two are both cube roots, but the radicands are different. And these are, again, both cube roots, but the radicands are different. Okay, so actually none of these can be combined. They're all different. So this is as simplified as possible. Okay, and then lastly over here, 20 is 2 times 10, and 10 is 2 times 5. Okay, so when I take the 2 out to join the negative 2, it multiplies. 45 is 5 times 9. 9 is 3 times 3. Okay, so that's going to be 3 squared times 5. Take the 3 out front. And then 6 radical 5. 5 is already prime. Okay, so the first two can combine. They're both radical 5s. -4 plus 3 is -1. Okay, and then we still have the plus 6 radical 5. Okay, so these are also like terms. They both have the radical 5. Again, if it helps, you can put a -1 there. Okay, so -1 plus 6 is +5, and you keep it attached to the radical 5. Okay, so really the rules for radicals are the same as they are for x, right? For example, if you had something like 3x plus x squared minus 5x, right? You can't combine these, but you can combine these. It's the same idea here, right? If you have two terms that can combine, you just combine those and leave the other one alone. All right, so questions about adding or subtracting? Okay, let's continue on the next page. We'll talk about multiplying. Okay, so if you remember, we did a couple multiplication problems last lesson, but our strategy was to turn the radical into a fractional exponent. So we're going to learn another method of multiplying. Okay, so the rules are different for multiplying compared to adding and subtracting. Okay, so the requirement for adding and subtracting radicals was both the index and the radicand need to match. For multiplying radicals, you only need the index to match. It's okay if the radicand is different. It's also okay if the radicand is the same. All you need is the index. Okay, so how do you actually multiply if you're allowed to? Okay, you take the coefficients of the two radicals and you multiply them together to get the new coefficient. Okay, and then similarly, you multiply the radicands together to get the new radicand. Okay, now you do not multiply the index. The index just stays the same. Okay, and then at the end, you simplify if possible. Okay, so this example below, 4 cube root 3 times 2 cube root 5. The two radicals have the same index, so we are allowed to multiply. Okay, so what you do is you take the coefficients and you multiply them together. You keep the index, so you keep it a cube root, and then you multiply the radicands together to get the new radicand. Okay, so normally I wouldn't write this, I would just do it, but I'm showing you this first time where the numbers come from. Okay, so 4 times 2 means the new coefficient is 8. Keep the cube root in the radicand, multiply together the 3 and the 5, the new radicand is 15. Okay, so you might notice that unlike the previous page where I simplified right away, here I said simplify at the end. The reason is you can take two fully simplified radicals, and when you multiply them together, they might not be fully simplified anymore. Okay, we'll see that in the future. Okay, but for now, let's check. Is this simplified or not? 15 is just 3 times 5. Nothing is cubed. Okay, so we can't simplify this particular radical anymore. Okay, so notice for this problem, there's no distributing because there's no plus or minus sign. It's just one term times another term. Even though the term has a coefficient and a radical, it's all one term. Okay, so let's compare that to this one over here. Here we do need to distribute. The parentheses is a binomial. There's a plus sign between the two parts. Okay, so we know that when you distribute, the outside multiplies this term, and it also multiplies this term. Right, so really what we're doing is the radical 6 is going to multiply the 3. And then the radical 6 is also going to multiply the 5 radical 2. Okay, so this first one, radical 6 times 3. So it's not radical 3, it's just 3. So when you multiply the coefficients, you've got invisible 1 times 3 is 3. And this radical 6 has nothing to multiply with, so it just stays how it is. Okay, now over here, again, first you multiply the coefficients. Invisible 1 times 5 is 5. And then now you multiply the radicands. 6 times 2 is 12. And last step, check if you can simplify. 6 is just 2 times 3. Nothing is squared. But 12 is 2 squared times 3. So I can take a 2 out to multiply the 5 and turn it into a 10. Okay, so don't forget, even though this started as a multiplication problem, after you distribute out, it's now an addition problem. So you cannot add these together because even though they're both square roots, they don't have the same radicand. Yes.
When you multiply the square root of 6 times 3, how does it 3 get to the other side?
It's just the way we typically write things. We write coefficients before the radical. It's just like how if I said for a different problem, x times 5, right? We don't say x5, we say 5x. So it's just the way we typically write it. Okay. You have a question?
I was just wondering about the vector 6 times 5 and 2, how they're stacked in the bottom.
So the first term is, it's technically invisible 1 radical 6, and it's multiplying the other term, which is 5 radical 2. So the invisible 1 times the 5 is where the 5 comes from. And then the inside 6 times the inside 2 is where the 12 comes from. Yeah, so, okay, good. All right, so please try the 3 problems below. Now that correctly combine them, future so in the initial problem, the 3 is not in a radical, so it's considered a coefficient. So technically you multiply the 3 by the invisible 1 in front. So the 3 should go on the outside because it doesn't start in a radical, so it's got to go in front instead. Yes.
Thank you.
Yeah. Good. Plus a negative is minus, right? Back over here, you combine them correctly, but you didn't simplify. So you kind of always check the radical and have stuff taken out. Okay. Problem 1. First, you multiply the coefficients. You've got invisible 1 times 5, so the new coefficient is 5. On the inside, the radicand 6 times 3 is 18. Okay, but this is not the final answer because the square root of 18 can be simplified. 18 is 2 times 3 squared. So when I take the 3 out, it multiplies the 5. So 15 radical 2. Problem 2. So here we would distribute. The 4th root of x would multiply the 3. And then it would also multiply the 4th root of 5. Okay, so first over here, 4th root of x times 3. Well, so again, you've got invisible 1 times 3. The new coefficient is 3. And this radical has nothing affecting it, so it just stays the same. Okay, so now over here, the coefficients are both invisible ones. So, I mean, technically it's invisible one coefficient here also, but we don't need to write it. Then on the inside, you've got x times 5 is 5x. Okay, and then this started as a multiplication problem, but now that you've distributed, now it's an addition problem. Okay, and the addition rule is the radicands need to match. Since they don't match, we cannot combine them. All right, and then over here, again, we would distribute. So the 2 radical 3 would first multiply the 4 radical 5. And then the 2 radical 3 also multiplies the 6 radical x. Okay, so doing this part first. On the outside, 2 times 4 is 8. Radical 3 times radical 5 is radical 15. Then over here, you've got -2 times +6 is -12. And on the inside, 3 times x is 3x. Okay, you check, can these combine? But no, they are not the same. All right, so do we have any questions on these first 3 multiplication examples? Okay, so these next 3 are still multiplication, but they're a little bit different. Okay, so here it's a binomial times a binomial. Both expressions have 2 terms. Okay, so we still apply the distributive property. We just do it a little differently. Right, so first the radical x will multiply this other radical x. Then that radical x will multiply this -4. Okay, so this one's done. It's paired up with everything over here. So you move on. This +3 will multiply the radical x. And then that +3 will also multiply the -4. Okay, so again, you've got 4 multiplications to do. So first over here, in front, invisible 1 times invisible 1 is still invisible 1. And on the inside, x times x is x squared. Move on. You've got invisible 1 times -4 is -4. And the radical has nothing affecting it, so it just stays. Here, you've got +3 times invisible 1 is still +3. And the radical x has nothing affecting it, so it stays. And at the end, you've got +3 times -4. 3 times -4 is -12. Okay, so again, this started as a multiplication problem, but now it's an addition and subtraction problem. Okay, so are any of these like terms? And this time the answer is yes. The middle 2 terms both have a square root of x. Okay, so we're going to combine those together. Okay, and then we can actually simplify this one too, right? We know that the square root of x squared, you take the x out. Okay, so in the end, we have x, -4 plus 3 is -1. So x minus radical x, and then -12. Okay, so just a reminder, we also could organize our work like this. Some of you may prefer to use the area model, right? It's a binomial times a binomial, so we do 2 terms in each direction. So you have radical x plus 3, radical x minus 4. Okay, so I would go radical x times radical x is radical x squared. Radical x times +3 is plus 3 radical x. -4 times radical x is -4 radical x. and minus 4 times positive 3 is minus 12. Okay, and then from there, it's the same work as here. Okay, so I'll ask you to try out problems 4 and 5 on this page. For problem 4, so 6 times 3 is 18. 6 times radical 5. It's 6 times invisible 1 in front is still 6. And the radical 5 is nothing to combine with, so it just stays. Then negative radical 2 times 3. So this time it's negative 1 times 3 would be minus 3. And the radical has nothing to combine with, so it stays. And then at the end, we have negative radical 2 times radical 5. So in front, negative 1 times positive 1 is negative 1. And inside the radicand, 2 times 5 is 10. Okay, so again, I just did the multiplication with arrows. I know some of you like to express it with the box, which is fine. Now I check, can any of these be combined? This has no radical, square root 5, square root 2, square root 10. Since it's now adding and subtracting, I need the radicands to match, but they don't. Okay, so this cannot be further simplified. Okay, and then lastly over here. So first, 2 radical 3x times radical x. In front, 2 times invisible 1 is 2. And then inside the radical, 3x times x is 3x squared. Next, the 2 radical 3x also multiplies the negative 4. 2 times negative 4 is negative 8. This radical has nothing to affect it, so it stays. Moving on, we have positive 1 times radical x. So anything times 1 stays the same. Then positive 1 times negative 4 is minus 4. Okay, so none of these can be combined, but we can simplify this one, right? We know that 3x squared, the x squared, the x can move out. So the 3 does not move out. The 3 does not have an exponent. It's only the x which gets to move out. All right, so questions about either of those multiplication problems? Yes, oh, that's okay. So if you, for example, wrote it like this, that's completely fine. Okay, any other questions? Okay, so we did addition and subtraction. We did multiplication. That leaves division. Okay, so moving on to the third page. Okay, so when I give you the instructions to fully simplify a radical, it is not simplified if there is a radical in the denominator. Okay, so looking ahead, right, neither of these would be considered simplified because they both have some type of radical in the denominator of a fraction. Okay, so we're going to split this into 2 situations. So the first situation is the denominator is a monomial, right? So that's a term we introduced way back in Unit 1. Remember, monomial means one term. Okay, so with a monomial, the denominator has no adding or subtracting. It's all a single term. Okay, so the way that we can rewrite this without a radical in the denominator. Okay, so I think it helps to sort of understand the goal before we talk about what to do. Okay, so the goal is to empty the radical. Okay, so we know that when you simplify a radical, if everything moves in front, then the radical is emptied and it disappears. Right, so that's how we can get rid of radicals in the denominator. If we can fully empty them, they'll go away. Okay, so I'll come back, but we saw that on the warm up a couple times somewhere. Were there not any on this page? Okay, I guess not, but we've seen before, right, that when you move everything out of a radical, the radical disappears. Okay, so that's our goal. We want to move everything out so the radical goes away. Okay, so how do we do that for like this problem, right? Because it's not 7 squared. So how can we move the 7 out when it's only 7 to the first power? Well, you need to multiply in whatever is missing. Okay, so you're going to figure out what you need to multiply the denominator by. And we know that with all fractions, if you change the bottom, you have to change the top equally. Okay, so I think this will make sense once we do these next two examples. Okay, so again, looking at this first problem, 5 over the square root of 7, we cannot move the 7 out. It's 7 to the invisible first power, but we know that a radical is a square root. Okay, so we're going to multiply by something. Okay, so let's just do times a blank fraction for now. Okay, but what do we multiply by? So it's sort of like what we did for completing the square. We're going to skip ahead a little bit, then we'll come back. Okay, so we multiplied the original problem by some fraction, and now it equals a different looking fraction. Okay, but we need to think about our goal, right? Again, the goal is to empty the radical. So in order for this radical to be emptied, it can't be the square root of 7 because the index is 2. We need to somehow turn it to 7 squared. Okay, so again, we're going to multiply the original denominator by something to make it look like this. Okay, so what would you multiply? Well, you got to multiply by the same type of radical, so it's still got to be a square root. And then we want to go from 7 to 7 squared. Okay, so to get from 7 to 7 squared, you'd multiply by 1 additional 7. Right, so just focusing on the denominator, ignoring the numerator, 7 times 7 equals 7 squared. That's a true statement. Okay, now if you multiply the denominator of a fraction, you have to multiply the numerator by the same thing. Okay, so up top, 5 times the square root of 7. The 5 multiplies the invisible 1 in front is still a 5. The radical 7 has no radicals to combine with, so it just stays. Okay, and now we simplify. The numerator, we can't do anything. 7's a prime number. But the denominator, remember the whole point was to empty the radical. So at this step of the problem, we are allowed to move the 7 out because its exponent of 2 matches the invisible index. Okay, so the regular 7 moves out, and now the radical is empty. There's nothing left, so the radical disappears from the denominator, which is what we wanted. Okay, and then now you check if you can simplify. You are not allowed to divide radicals by non-radicals. So even though these numbers are both 7s, you cannot cancel them out. Now the 5 and the 7, if they had a number in common, you could cancel them out, but they don't. Okay, so this is the fully simplified answer. Okay, so again, the order, you want to think ahead to the goal. The goal is you want the radical to empty in the denominator. It's okay to leave radicals in the numerator, but not the denominator. All right, let's do this one. So this one's a little different because this is a cube root, not a square root. So the first part's the same. We're going to multiply by a mystery fraction. Okay, but our goal is going to be different this time, right? In order to make the radical empty, because it's a cube root, we need everything on the inside to be cubed. Okay, so this 5 needs to end up cubed, and the x also needs to end up cubed. Okay, so again, please make sure you think about the reason, right? Why are we trying to get here? Because if we can turn the bottom to look like this, the 5 gets to move out and the x gets to move out. The radical would be empty. Okay, so before I continue, are there any questions about the reason that we're trying to get to here? All right, so then now we need to figure out how do we get there? Okay, again, the original problem does not equal that, so we have to multiply in the missing factors. Okay, now you always multiply by the same type of radical. So make sure you do a cube root right here, not a square root. Okay, so you're already given a single 5 or a 5 to the first power at the beginning of the problem, but you want to end with 5 to the third power. Okay, so what do you multiply 5 by to get to 5 to the third? You've got 1, but you want to end with 3. So you need 2 more. So you multiply by 5 squared. Okay, now what about the x's? You're starting with x squared, and you need to end at x cubed. Okay, so you start with 2 to end at 3. You just need 1 more. Okay, so you would just multiply by x, or x to the first power. Okay, so again, make sure you understand where this part comes from. It's the missing pieces that take the original denominator into the goal. Again, original denominator is only a single 5, so you need 2 more 5s to get to 5 cubed. Okay, the original denominator already had x squared, so it only needs 1 extra x to become x cubed. Okay, so now that we know what to multiply the denominator by, you multiply the numerator by the same amount. Okay, so up top, the 2x has no coefficient besides invisible 1, so it just stays at 2x. And the radical has nothing over here to affect it, so it just stays the same. Okay, so now let's try to simplify this radical. So I'll start in the denominator. The 5 gets to move out, and the x gets to move out. There's no more radicand, so the radical disappears. Okay, that's great. Up in the numerator, we still have the 2x. Now, can we move anything out? The 5 squared does not meet the requirement of an exponent of 3. Okay, now instead of leaving it as 5 squared, I'm going to multiply it back together to 25. Okay, in your final answer, you should never have a regular number to an exponent. Okay, and then the x does not get to move out either. Okay, so we're not quite done yet, but let me see if there's any questions on how I got from this step to this step. Yeah.
So just like make sure, to multiply.
Okay. Okay, so lastly, we need to see if we can reduce. The 2 and the 5 cannot reduce. They don't have a common factor besides 1. And remember, you cannot divide a radical by a non-radical. So you cannot divide the 25 and the 5. You cannot divide this x by this x, but you can divide the outside x with the denominator x. All right, so this x and this x, they can cancel out. They are both factors of their respective rows, so they can be divided away. Okay, so you can just get rid of the 1x from each section. And that leaves us 2 cube root 25x in the numerator over 5 in the denominator. All right, so please try the next 3 problems. I would not move on to the next part. The rules for the bottom 2 are different, but go ahead and try the next 3, please. For problem 4, our goal is to get to the square root of 6 squared. So we already have a 6 to the first. So to get to 6 to the second, you just need 1 additional 6. Right, so now that 6 gets to move out. Sorry, that should be 18 up top. Okay, but we don't stop here. We check if this square root can be simplified. And 18 is 2 times 3 squared. Okay, so you can take the 3 out. All right, and then we cannot reduce the 2 and the 6. The 2 is inside a radical, but you can reduce the 3 and the 6. The 3 and the 6 can both be divided by 3. So that takes us to radical 2 over 2. For problem 5, it's a cube root, not a square root. So the goal is to get to the cube root of x cubed. To get there, we already have an x to the first power, so we would need to multiply by a cube root of x squared. Okay, make sure you put cube root and not square root. That's a common mistake. In the numerator, the 7 multiplies invisible 1. It's still a 7. Then we have the cube root of x squared. In the denominator, we can take this x out. Okay, we cannot simplify the numerator. The x doesn't have a big enough exponent to match the index. And we cannot reduce the x's. Again, you can't reduce radicals with non-radicals. Okay, so this is, maybe it's an accident. Okay, so for this last one, it's a fourth root. So to empty it, we need everything inside to be to the fourth power. Okay, so the 2x, both of these are currently to the first power. So to get from 1 of something to 4 of something, you need 3 more. Okay, so we would multiply by 2 cubed x cubed. Okay, so the x in front just stays in front. 2 cubed cannot move outside, so I'm just going to turn it back into 8. Okay, and then in the denominator, again, the whole point was to move everything out. So the 2 and the x move out. Okay, and then I'm guessing some of you got to here, which is great, but this is not the final step. Again, you can't reduce these x's, but you can reduce these x's. This x on the outside and this x in the denominator are common factors. So the fully simplified answer, the fourth root of 8x cubed over 2. All right, so we have one last topic. So this is still division, but the denominator is now not a single term, it's a binomial, right? So there's 2 terms separated by a plus or a minus. Okay, so the previous strategy will not work. Okay, so you don't need to write this, but please just watch. So like before, if we had a radical on the bottom, you would just multiply by that same thing. The problem is, because you have to distribute, you fix this one, this is no longer a radical, but you create a new radical over here. Okay, so the old strategy won't work. Okay, so what do we do instead? Okay, when the denominator is a binomial, okay, you're going to multiply both the top and the bottom of the fraction. Okay, so you're going to multiply by something called the conjugate of the denominator. Okay, so what does the word conjugate mean in a math sense? All right, some of you have probably heard it in your language class for like changing verbs around. But in math, the conjugate, the conjugate of something is identical except the middle symbol is switched. Okay, so I'll show you an example. But after you do that, don't forget you always check to simplify at the end. All right, so let's look at this example together. Square root of 5 over the quantity 5 plus the square root of 2. Okay, so for this problem, we don't need to think ahead to the goal. We know right away what to multiply by. Okay, so it's not the denominator, it's the denominator with the middle symbol switched. Okay, so you keep the 5, you keep the radical 2, but instead of a plus sign between them, you do a minus sign. Okay, so again, with binomials, you know right away what to multiply by. And you do not do the conjugate of the numerator. You multiply by the exact same thing as the denominator. Okay, so you would want to put parentheses around your binomials so that you remember to distribute. Okay, so let's see how the denominator multiplies out. Okay, so I'm going to organize it this way. Okay, so I've got a 5 plus radical 2 times 5 minus radical 2. Okay, so I know that to distribute, I have to do every pairing. Okay, 5 times 5 is 25. 5 times radical 2, the 5 goes in front. The radical 2 is attached. 5 times negative radical 2, in front, 5 times the negative indivisible 1 is now negative 5. Keep the radical 2. Okay, and at the end, we have negative 1 times positive 1 on the outside becomes negative. And on the inside, okay, so 2 times 2 is 4, but I'm going to write it as 2 squared. Because now I can take the 2 out front to make it negative 2, regular 2, right? So the radical is emptied. Okay, so overall in the denominator, I have 25, and then positive 5 radical 2, minus 5 radical 2, and then minus regular 2. Okay, so these middle two are like terms, but they actually completely cancel out, right? Positive 5 of something minus 5 of that same thing, that would be 0 radical 2, which just goes away. Okay, so then I have 25 minus 2. So this whole thing simplifies to a single number, 23. Okay, so remember, you're not allowed to have any radicals in the denominator. So if you still have a radical at this step, that means you messed up somewhere. Okay, now what about the numerator? Here, it's a monomial times a binomial. So I'm just going to do it like this. Radical 5 times regular 5. The regular 5 goes in front. The radical 5 is attached. Then you have radical 5 times negative radical 2. Positive 1 times negative 1 is negative. And then on the inside, 5 times 2 is 10. Okay, so you cannot simplify anything. So this is the final answer. Okay, so let's just do a little bit of this last one together. Okay, so first, please figure out what are we going to multiply the denominator by? Okay, so it should be the conjugate of the denominator. So you keep the negative 1 in front, you keep the 2 radical 5 at the end, but instead of a minus sign between them, you switch it to a plus sign. Okay, so you would multiply both top and bottom by negative 1 times, negative 1 plus 2 radical 5. Okay, and then go ahead and try to simplify the denominator. Don't worry about the numerator, but let's see if we can at least do the denominator. All right, so I went ahead and put up the work on the board. Okay, so remember, you should not have a radical in your final denominator. If you did, that means you should have known you made a mistake somewhere. Okay, so the rest of this problem and the back page are on Canvas. So tonight's homework is a little bit different.